Hi everyone. So everybody's been kind of freaking out about blood typing. But I'm going to show you this is actually pretty easy. If you could do the rabbits with the different fur color, this is a piece of cake. Okay, so our first question says list the possible genotypes and phenotypes for each trait separately. Okay, so we have a lot going on here. We know that our trait is the ABO group. I have the alleles of a capital I with an A on it, that's A. Capital I with a B is B, and a little I is no protein. Okay, no A's and no B's. I know that A and B are codominant, and that A is dominant to I and B is dominant to I. Okay, so my alleles are IA, IB, and little I. How many different ways can I write those? We're just going to distribute. IA can be with itself, with a B, or with a little I. Okay, now I can go to the B. IB can be with itself. I've already got it with an A, so IB with a little I. And then I have a little I and a little I. Okay, our next one is the RH factor. I have a capital R gives me the RH, a little r means no RH. And then I know that RH is dominant to not having it. Okay, so that means I could have this, this, or this. That looks familiar, right? Okay, now this was blood type A, AB, A, B, B, and O. This is RH positive, this is positive, and this is negative. Next, we have this other protein. It's MN. And it doesn't even matter what protein this is. It doesn't matter what it's called or where it is. Our same rules apply. Excuse me. We have M's and N's, and they are codominant. So for this, I can have IM with an IM, IM with IN, IN with IN. Okay, now this gives me M, this gives me MN, and this gives me N. Now lastly, I have these P and P prime, and they are also codominant. So same thing's going to happen here. I can have two P's, a P with a P prime, or a P prime with a P prime. This gives me P, this gives me P prime, and this gives me P prime. They're just proteins. Okay, so let's take a look at what our question is. How many total genotypes and phenotypes are there for all of the 4 traits considered together? So let's look at our genotypes. Now, if you remember how we figured that out before, okay, 1, 2, 3, 4, 5, 6. We have 6 genotypes here. We had 3, 3, and 3. We multiply. Okay, we get out our handy calculator. Six times 3 times 3 times 3 gives me 162. So there are 162 different genotypes I can make with all these combinations. Okay, now if we go for our phenotypes. Oh, I forgot to write them down here. So this one is A, AB. That one's A, but I've already got it. This one's B, this one's B, this one's O. So how many different ones do I have? I have A, AB, B, and O. So I have 4. How many different phenotypes do I have here? 2. How many different ones here? 3. And how many different ones here? 3. So I do 4 times 2 times 3 times 3. There are 72 different phenotypes. So this is pheno, this is genome. So our phenotypes equal 72. The next question. A woman is type A. Okay. She's positive. She's MN and she's P. What are her genotypes? Okay, so to be type A, I can either be this or I can be this. All right, now to be positive, I could be this or this. To be MN, I can only be that. And to be P, I would have to have that. So now I need to see how many ways can I combine this. Well, let me use some color here. It'll make it a little easier to see. I could go here like this, or I could go this way. But I could also start with this one and go this way. Or this way. So there are 4 different genotypes. It can be I big A with a big R, I M, I N, P, P. That's one of them. Okay. Another one. Okay, that's 2. See if I can get the third one up here. And the fourth one here. So there are four different possible genotypes for this one person. Next, it says a man is B, so that means I could be either of these. Negative. Now, there was only one way to be negative. N and PP prime. So that means for this person, I could be this, or I could be this. Not as many choices here, so only 2. So I could have oops, I put a prime there when there shouldn't be. I need to go back to my problem here. So it's P, P prime. Or the other option is that. So far, I haven't had to do any crosses at all. Hasn't asked for any crosses. A child is type O, positive, MN, PP prime. What are the child's possible genotypes? Same thing happens here. For O, I have to be like this. For RH positive, I could be this or this. And for forgot my I's. I-M-N-P, P prime. So that means, again, we have two ways we could do this. Or the other way is like that. Okay, could the man in 4 be the child's father? So that means I have to compare 4 and 5. So let me make this a little bit easier. Okay. So if this child is little I, that means I had to get one from mom and one from dad. Well, there's no little i's, so if the dad is this genotype, it couldn't be the father. So let's look over here. Little I, it could get a little I here. So R's, it had to get one of its R's from dad, and dad only has little R's. So if the child is this one, maybe. And then it had to get an M or an N from dad. Could have gotten an N. Could have got a P or a P prime. So this one could match with this one. So could the man in 4 be the father? Possibly, if the father has this genotype and the child has this genotype. So now if we know what the child's genotype we have here, what about the woman? Could the woman be the mother? So let's take a look at mom. Okay. What genotype does the child's mother have to be? So if we look here, we know that the child got little i's. So it can't be this one. It can't be this one. It would have to be one of these two. We know that the child got a big R and a little r. Well, it could be either one. Okay, we have here an M and an N for the child. Okay, could have got this or this. Oh, and then look, P or P prime. Could have gotten either one. It would have to get the P from mom. Couldn't have gotten the P prime, right? So it would have to be one of those. But can it be, yeah, if this is the dad, then it's a different story. Okay, so if this is the dad, then it would have to be no, it could be either one still. Okay,